Alright, so week 14, notes part 1, we're moving on to solving systems of equations is what this is described as. So what that means is we have two different equations, and these look like equations of lines, and what we're going to do is we're going to find the point where they cross, which is the value of x and y that makes both true. So you start out by basically graphing these, and it's really important that you are nice and neat because we're interested in where they actually cross. So we'll set up our axes, and you're remembering slope-intercept form. So I'll color code here. For our first line, we know that the slope, m is the variable we use for slope, is 1, so we can use 1 over 1, and our y-intercept is -3. So we start down at -3, and we have a slope of 1 over 1, so we're going to go up 1, over 1, up 1, over 1, up 1, over 1, and we can continue that pattern, and we could continue that pattern backwards. So using your ruler, nice straight line, like so. And then for this next one, we have a slope of -1, so I'm going to use -1 over 1 for my rise and run, and it looks like the y-intercept is 5. So up at 1, 2, 3, 4, 5, we start, and then we're going to go down 1 and right 1, so I can use the highlighter. Down 1, right 1, 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 etc. So we have all these points, and using my ruler, I could draw a nice straight line, and we're seeing that these lines cross at an exact point, and that point is 4, 1. So for the solution, we can write this a couple different ways. We can say 4, 1, that's the point where they cross. We can also say x equals 4 and y equals 1. This is the same thing. And if you look at either equation, if we take the points, if we plug in a 4 here, -4 plus 5 is equal to 1. And up above, if we take 4, plug it in here, 4 minus 3 is equal to 1 as well. So these are the values that work in both of those equations, and we found it by graphing the lines and seeing where they cross. So it's important, again, that you're very nice and neat. So let's see how this works. All right, solved by graphing. So for our top line, I'll use blue. We're starting down at -2, and we have a slope of up 2, right 3, 2/3. So up 2, right 3, up 2, right 3, and we can continue that pattern backwards and backwards. And if you're confused about which way to go backwards, if the points are in a straight line, you're doing it correctly. Okay. Next up, we have a slope of -1, so we're going to go down 1, right 1, and a y-intercept of 3. So starting up at 3, and we go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, etc. And our nice, straight, beautiful line would look something like that. And it's pretty obvious that they're crossing at a specific point. So that's right here, and this is 1, 2, 3, 0. So x is 3, y is 0. So our solution would be 3, 0. And we could say x is 3 and y is 0 for our solution. Okay. Next up, so we have slope, down 1, right 2 for slope with -1/2, and a y-intercept of -2. And then here we have a slope of 1 and a y-intercept of 1. So we be graphing. Set up our axes. Nice and neat. And so starting at -2, and I have a slope of -1/2, so I'm going down 1, right 2, down 1, right 2, and I'm going to continue that pattern backwards, over 2, up 1, over 2, up 1. so that these points are all in a nice straight line. And then, so I have a y-intercept of 1 and a slope of positive 1. So for this one, slope positive 1. So we're going to go 1 over 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And so I see that if I'm just drawing my line like this, they're not yet crossing. So I have to continue that pattern backwards. Cool. Looks like they're going to cross. So continuing that pattern backwards, nice straight line. And it looks like the points cross, the lines cross here. And so that is -2 for x and -1 for y. So we could write it that way. We could also write x equals -2 and y equals -1. And those values, if we put them in both of these equations, it will work. All right, so last step before the now you try. Let's see, so we have a slope of -1, y-intercept of 4, and a slope of 2, and a y-intercept of 1. So, set up our axes, nice and neat. And we're going to start y-intercept of 4 for this, and then our slope is a -1. So I'm going to write that as -1 over 1. So we go down 1, right 1, down 1, right 1, down 1, right 1, etc., etc. And connect them, nice straight line. Using a different color so we don't get confused. What does that say? 2x plus 1. So we have a y-intercept of 1, and then for our slope here of 2, I'm going to go 2 over 1. So I could go up 2 and right 1, and up 2 and right 1, and up 2 and right 1, and connect them, nice straight smooth line. And it looks like they are crossing at a specific point. So that is x equals 1 and y equals 3. So x equals 1, y equals 3. So I can write that. This is called an ordered pair. It describes the coordinates of a point. I could also write that as x equals 1 and y equals 3. Okay, so it's now time for the now you try. And what I'd like you to do is check these. You can type these into Desmos, and it's going to show you a nice graph, and you can tap the place where they cross, and it will tell you this, so you can actually check your answers. So go ahead and do that. Thank you.